All right, here we are. So we have a lot to do today. In particular, let's go back for a second to Moodle. We're basically done with chapter 8. And so that means it's time to do a problem set. So first let's go get it and see what that's all about. Okay, here we go. Moodle. And hold on, let me log in. All right. Okay, so yeah, so chapter 8. We finished it up, I believe, last time. Let's double check. That's right, because we were looking at all those problems with annuities and solving for the payment in an annuity. So for example, if you want to borrow money to buy a car, the payments will take the form of an annuity of monthly payments for X years. And so you might want to ask yourself how much will be the monthly payments, because that's really what ultimately determines whether you can afford to buy that car or not. And so it's a very important question. So that was one of the last things that we did. In fact, it was the last thing that we did. So this chapter is done now. So now we're ready to dive into the problem set, which is also right here somewhere. Yeah, it was better. You know, I started to run out of space. Let's see. I'm trying to keep everything together. Oh no, did I forget to post it? Oh, that's very bad. I guess it isn't here, is it? Sorry about that. All right, well, you know, we can go over it anyway, because I'll just show you what the questions are and we'll go over it together. You'll get another opportunity to work on these problems anyway, because this is the entire content of the second midterm rather. And so there will be a sample midterm number 2, which, oh, there it is. Sample midterm number 2 is entirely based on chapter 8 as well. So let me go get the questions. And then I'll just post them up there right now. Okay, here they are. All right, so here they are, right there. All right, so what do they look like? Well, I mean, it's exactly what we've been doing, but it's broken up into some interesting ways. So for example, right here, let me just save this. Okay, so let's look at this first box. Now you see it's written this way. If you wanted to, you could fill in all your answers directly in these cells in the box. Basically, with these first 8 problems, you're being given 3 pieces of information, and you're being asked to calculate the one that's missing. Now, these are all based on that relationship that we saw in the chapter. Simple interest is PRT. Okay, so remember, I is, let's put this over here. I is simple interest. P is principal, the amount you either borrowed or lent. R is the rate of interest, which is a percentage. And T is time measured in years. Okay, keep that in mind, it's in years. So if you look at the first row, you'll see that you're given P, R, and T, and you're being asked to calculate I. So let's do it. So for number 1, I equals PRT. And then you'll be able to just directly type in the numbers, which means 12,000. Now, as far as the rate of interest is concerned, make sure that you convert that into a decimal before you enter this into the problem. Otherwise, you're going to get the wrong answer. So whenever you enter percentages into any kind of a word problem or any other algebraic problem, the first thing you always want to do is convert it into a decimal. All right, so if you multiply those numbers out, you'll find that the simple interest is 1440, exactly 1440. So I can type that in here now. And I'll highlight that to remind us that this is the piece that we were looking for. All right. Now for number 2, it's going to be very similar. I equals PRT. So you can see that you multiply the principal of 25,000. The rate of interest is 0.85 or 8.5%. Now this one is tricky because 6 months, don't put 6 here. 6 months can be converted into 1/2 of a year. So remember, T is measured in years. So you want this to be 0.5, not 6. Okay, so anyway, when you multiply those out, you'll get 1062.50. And in these cases, by the way, you should always round to dollars and cents because that's how the bank would calculate it. If there's more decimals, you can just feel free to round them to the 2 places so that you're rounding it to dollars and cents. All right. If it's a dollar amount, that is. Okay, now number 3 is a little bit different because if you notice what's missing is T. All right, so remember we were able to rearrange this basic formula to solve for any of the missing pieces. So with T is equal to I over PR. And how did we get that? By taking this equation, we divide both sides by PR so that T is left by itself on the right-hand side. And this is the formula that we will use. So in this case, the simple interest is 1,800. And we divide that by, oh wait, sorry, I looked in the wrong column. The simple interest is way over here on the right. It's 360. We divide that by the product of the principal and the rate, which is 10%. Now, here's a helpful hint. On your calculator, when you divide like this and you have a product in the denominator, make sure you use the parentheses. Otherwise, you're going to get the wrong answer. So in other words, this one reduces to 360 over 180, which is 2 rather. And that tells me that this is a 2-year loan. So I'll fill that in. So again, be careful whenever you're dividing and multiplying at the same time. You need to be very, very careful with your parentheses. So in this case, you will need them in your denominator. Oops. There we go. All right. So let's say, for example, just as a quick look at this. Hold on one second. You would go to your calculator and type 360. Oh God, I don't think we'll do ice blue. How about black? It's so much easier to see it. 360 divided by open parentheses 1800 times 0.10 close and equals. That should take care of it. All right. If you left out the parentheses, it'll think you mean 360 divided by 1800 and then times 0.10, which is not what you want. So that's awfully important. All right, so I'm going to quickly confirm that on mine. Yep, that's it. All right, so those would be the steps you would follow on your calculator. All right, what about 4? Now 4 is the same as 3. It's also a time question. And you'll see this time, though, that the simple interest is 72, and we divide that by the product of 600 times 0.04, which is the same thing as 72 over 24, which gives us 3. Now, you don't have to break it up like this. If you just type these keystrokes directly, you'll get your 3. But I just wanted you to see why this, why this is happening. Beautiful. Now, the next two, you notice the box that's missing is the rate. So the rate formula is I over PT. And again, it's for the same reasoning. If you go back to the original equation and divide out both sides by P and T, you'll be left with a solution for R. All right. So here we've got simple interest on the far right of 1290 over the product of the principal of 4,300 times 6 for the number of years. And that's going to give you 0.05, which if you choose, you can rewrite that as 5%. Either way, it's fine. 0.05, 5%, they mean the same thing. All right, so all the questions that involve the rate will be done in the exact same way. And again, don't forget the parentheses. Nice, all right. So the one, like I said, directly after is the same, except for the numbers. It is also a case where we're looking for the rate of interest. So we're going to have, in this case, let's see, 45 over the product of 203. And that gives me 0.075, which of course is the same thing as 7.5%. Beautiful. All right. Now, how about number 7? Now with 7, you notice the missing box. Oh, I almost forgot. The missing box is principal. So we have to solve for P now, taking the same starting equation, the simple interest equation, P is equal to I over RT. And so for this example, that's 354.60 over the product of 9% times 4 years. And that worked out to be $985 and no cents. All right, once you take a minute, confirm that with your calculator. All right, now the box only has one more row. This is also a principal problem. Here we have 65,625 divided by the product of the rate, which is 15%. Whoops, 15 is 0.15. And 7 is the number of years. And that works out to $62,500. Oh, I almost forgot to put them in here. 985 and 62,500. And that's it, we're done. So no matter which one you're being asked to do, it's just a question of taking the simple interest formula, rearranging it algebraically, and coming up with the one that you need. Also, don't forget about the parentheses, and make sure that the rates have been converted into decimals. That's all you have to remember. So you shouldn't have any trouble with any of these. The later ones, maybe not. We'll see, but these are pretty straightforward. Always just don't forget about this right here. That's where it all starts. I equals PRT. Okay, I think we're done with those. And we don't need this box anymore. So what's going on here? Now, here we're looking for a future value. Now, when you see the words future value, you know we're looking for one of the formulas that involves A. Because remember, in this book, A represents future value. And this means how much a sum will be worth in the future. Well, actually, I shouldn't say it like that. We also saw that same letter used for annuities. So how much a sum or an annuity will be worth in the future. Anyway, look at it. This tells me how much money I'll have in the future, given the amount that I'm investing today. Now, here's the question, though. Which formula should I use? Well, this tells us right in the problem that we're using simple interest. And that means that we're not using the complicated formula that it has compounding frequencies in it. If you recall from way back in the beginning of the chapter, we saw that this can be written as A equals P plus I, or A equals P times 1 plus RT. Okay, so when using simple interest only, the future value formula is, and you can use either one of these. It's up to you. I usually prefer the second one. So here's the scenario. You start with $800, and then you multiply that by 1 plus the product of 0.04 times 5. And so what you might want to think about doing here is simplifying. And that makes it so much easier because you're adding 1 plus 0.2 or 1.2. And that means that in 5 years, you'll have $960. So all 4 of these will be done in exactly the same way. The only change will be the numbers you're given. All right, so let's look at this one. A equals P1 plus RT equals 15,000. 1 plus the product of 0.09 times 7, or 15,000 times 1.63. That gives me 24,450. All right. So 0.09 times 7 is 0.63. When added to 1, that's 1.63. And so that's our final answer. That's not a bad rate of return. You've added roughly 50% to your balance. But that's because you're getting a 9% rate of interest. That's a very high rate of interest at this point in time. Don't expect to get that in a bank anytime soon. All right, now for this one, we've got 700 multiplied by 1 plus 0.10 times 6, which is 700 times 1.10. 6, and 1.6 times 700 is 1120. Okay, so again, you can confirm that 0.1 times 60 is 0.1. When added to 1, it becomes 1.6. And so what that means is that you'll end up with 60% more than you started out with. So 700 multiplied by that is 1120. All right, and one more. It's exactly the same setup, except that this time 6 months is the time frame. Now remember how we discussed that earlier. Don't put 6 in there. That will be treated as half a year. So we'll have 0.085 for the R, and that's multiplied by 0.5 years. So what you've actually got here is 1250 times 1.0425, and that's going to leave us with 1303. If you round it to dollars and cents, 1303.13, although it's actually 0.125, we round it up to the nearest cent. Okay. All right. 1303.125, which we round to 13 cents. All right, so far they've all been pretty straightforward, and that's partially because they're all based on simple interest. But up here, we reminded ourselves how to use this formula multiple ways, and down here, we're reminding ourselves how to calculate future values based on simple interest only. Now we've got some word problems, but before you panic, just keep in mind, many of these word problems are just straightforward extensions of what we've just been doing. So let's see what we've got here. All right, we have Jane. And what's going on with Jane? She's trying to borrow, or she had to borrow, $8,000 over 6 years to finish her education. And so what are we being told? The principal is $8,000. The time is 6 years. The simple interest is $4,046.40. Now, it says, what is the rate of interest? So in other words, we're looking for R. So if you recall from up here, when we solve for R, it was equal to I over PT. All right, so that means we're supposed to plug in these numbers and solve for R. So literally all we have to do is fill in the numbers. 4046.40 over the product of 8,000 times 6, or 4046 times 40 over 48,000. And that turns out to be 0.0843 or 8.43%. All right, so once you throw those numbers in your calculator and make sure you're getting the right numbers. Okay. So you can see it's a word problem, but it really is nothing but exactly what we did with the box, except there we just had the numbers. Now we're finding out what exactly is going on behind the scenes. All right, good. All right, now how about this one? Fred starts up a new e-commerce business. He borrows $15,000. So already we know the principal is $15,000. for 12 years. He's paying simple interest of 18,000. Oh, well, this is the same type of problem. What do you know? We want to know how much interest he's paying if he's going to end up paying $18,000 worth of simple interest. Beautiful. So then we'll have 18,000 over the product of 15,000 times 12 years, 18,000. Now 12 times 15,000 is a very large number. In fact, it's 180,000. That works out nicely because you can see that the rate of interest is simply 0.10 or 10%. A nice round number. Okay, I like that. Nice round number. All right, now, what about this one? We are buying 2 copiers. The campus bookstore is paying $13.50 in simple interest because they're borrowing the money, of course. It's a 9% loan, and it will take place over 3 years. And so what we're asking for here is to solve for the principal, or P. So if we revisit our formula for simple interest, actually, we don't even have to do that. We've already figured out for ourselves that, here we go, P equals I over RT. And again, it's taken directly from the simple interest formula. Okay. So let's plug them in. P equals 1350 over the product of 0.09 times 3, or 1350 over 0.27, and that works out to be $5,000. So in other words, in order for all this to be true, they must have borrowed $5,000. Very good. So it's pretty straightforward. I mean, the whole idea, there's no intention to be tricky here. It should tell you in the problem which of these 4 components you're actually being asked to calculate. Okay, and of course, in all cases, you have to be given 3 of the 4 numbers so that you can figure out what the 4th one must be. Now, this can be used in a few different ways. Imagine if it had been worked around the other way and the campus bookstore said, we can afford to pay $1,350 in simple interest. We know the bank charges 9% and they're willing to give us a 3-year loan. How much can we borrow? And the answer would be we can borrow a maximum of $5,000 under these conditions. And that might be helpful to us to go out and find the right copiers. So, there's a lot of useful ways we can use this information. All right, now here we go. To train employees to use its new equipment, the Williams Muffler Repair Company had to borrow $4,500. That's our principal. The rate of course is 9.5%, which we will naturally enough convert into a decimal. And the simple interest is $1,282.50. Find the term. Now, just a quick reminder, the word term means the same thing as time in this situation. All right, it's not a new term. It's not a new word. Just a quick reminder. Term equals time. But when it comes to borrowing and lending, we often see that word term used instead of time. It just means how long will it be before you either have to repay your loan or until you will take back your investment or you want to cash in your investment. Okay, so just remember that the word term means time. And luckily they both start with T, so that should be very helpful too. So if you forget, just remember it's T. All right, now remember, again, we're going to go back and revisit the first question. Here we go. We definitely did one of these. And now I lost my place. Here it is. Here it is. So again, we just plug in the numbers. We'll have 1282.50 over the product of 4,500 and 095. If you multiply out 4,500 times 0.095, you'll get 427.50. And so the ratio of these two numbers is exactly 3 years. Now, if you notice in these problems, the time keeps turning out to be even numbers of years, 3 years, 5 years, sometimes 6 months, but that's because normally when we borrow money, it's for even numbers of years. You wouldn't normally find, I mean, it's not impossible that you'd borrow it for a peculiar number of years, like 2 3/4 years or something like that, but it's not common. Normally you borrow for even lengths of time. So if you go to the dealer and to buy a car, they're going to offer you loans of anywhere from 3 to 6 years. That's pretty standard. But you're not going to be offered 3.7 years. It doesn't work that way. All right, now here's one more. Here's another term loan question. So Berger borrows a principal of 86.50, 6.8% interest, and the simple interest I is 441.15. Now you can see this one is exactly the same because we're asked for T. So we're going to use this formula again, and we'll plug in some numbers. T equals 441.15 over the product of 86.50 and 0.68. You can simplify this if you want to 441.15 divided by 86.50 times 0.068 or 588.20. And that ratio doesn't look good, does it? But no, it's 0.75. Now, 0.75 years is actually just 9 months. So here's one of those cases where it was a short-term loan and they borrowed for 9 months, which is 3/4 of a year. All right. So now those are done. Now we're ready for the scary formula. How do you know? Because it has the word compounding frequency in here. And it says here that we're being asked to calculate the compound interest as well as the future value. So this is where it's starting to get just a little bit messier. All right, so first things first, if you notice in each of the cases, we need the future value from which we can figure out the compound interest. So this is a multi-step process. Remember, this one we do not have a formula for. In fact, let me go grab chapter 8 again so we can borrow that formula. You know the one I'm talking about. Okay. Now, there it is. This is the one. Yes, that formula. Which, if you recall, of course, let's just repeat all the terms here. A is the future value. T is principal. R is the rate of interest. N is the compounding frequency. And T is time in years. So we'll use that for all of 4 of these to first find the future value. Once we have the future value, we can figure out the compound interest. All right, so first let me split the screen. And we'll start with the first one, 18. And we're told that P is 825, R is 0.04, compounding frequency is annually. So the interest is compounded once a year. In fact, you know what I'm going to do? Let me just quickly enter these into the chart. They weren't there before, but I just want to remind you what these numbers mean. All right, so I just want to remind you what those n's are all about. So n is 1 in this case, and then t is 10. Now, this is the one we have to be extra careful. We have to go out of our way to simplify it as much as possible. Otherwise, you're just going to have a mess of parentheses, which is not going to work out too well. Or it might, but it's going to be a lot harder. So here we have 825, 0.04, n is 1, which makes things a lot simpler. 1 times 10 is the exponent. Now, this one is especially simple because really all that you have here is 825 times 1.04 raised to the 10th power. So as we've already discussed, most likely you're going to be able to get the answer more easily if you do the 1.04 to the 10th and then multiply the result by 825. If you go from left to right, it'll work, but you have to be super careful with the parentheses. So I really think you're better off going from right to left in this case. Start with the messier part of the expression and work your way back to the easier part, I guess. And this turns out to be 1221.20 when rounded to dollars and cents. Now, that's only part of the question. Because remember, they also asked us to figure out the compound interest. So what we should do here is this. Total interest, you can think of it as A minus P, which is 1221.20 minus the principal of 825. That's 396.20. All right, so very simply, the total interest must be the difference between what you end up with and what you started out with. In this case, 396.20. And then of that, simple interest is easy because that's just PRT, which is 825 times 0.04 times 10 years, which is $330 even. And now the important detail is that compound interest equals total interest minus simple interest, which is 396.20 minus 330, which is 66.20. So that's all you have to do. But I mean, yes, there's a lot of steps here because you have to not only figure out the future value, but then you need to go through all these steps to come up with the compound interest. All right, has everyone got that? Oh, there's a chat. Sorry. Yes, you got it. Okay, great. Yeah, it used to be this thing would flash orange when I had a chat. It doesn't do that anymore. That makes it very hard to see when somebody's chatting. So if I don't see it, I apologize in advance because it's just not that obvious. All right, now the whole box is done in exactly the same way. All right, so here's what I'm going to do. I'm going to challenge you right now to try number 19 all by yourself, okay? Without, I mean, just watching, I'll leave this here. This is 18. What I want you to do is try 19, give it a couple of minutes, and then try 19, and then we'll go over it, and then we'll do the same thing for the others, because this is really one of the more complicated problems you'll run into. And I want to make sure everybody really and truly understands it. All right, so once you take a couple of minutes and try 19, all right? All right, let's see how we did. So for 19, P is 3250, R is 0.02, N is 1, and T is 5. Plug in the numbers. I'll just steal this. And we'll have 3250 the rate is 2. It's once again, it's annual compounding, which makes things a lot simpler. And so you've got 3250 times 1.02 to the 5th power. So if you multiply that on your calculator, 1.02 to the 5th, you get 3588, rounded to dollars and cents, 3588.88. 26. So then what we want is the total interest. I'll just borrow this and change the numbers. So we would have the future value 358826. The original principal was 3250. $338.26. Great. Now the simple interest is 3250 times 0.02 times 5 years, which is $325 even. So the difference between the two is 338.26 minus 325 is $13.26. All right. So once you have the right future value, the rest is fairly straightforward. You're just trying to pick apart how much interest you've earned, of which how much is simple and how much is compound. Beautiful. All right. Well, you know what that means. I think why don't you take a shot at number 20? All right. I'll give you a couple of minutes and you can look at 20, and it's the same exact procedure. Actually, let me leave this here so you can follow along if you've forgotten how it works. Just apply these techniques to number 20 and let's see how you do. All right. Well, first let's gather up the numbers. E is 75. R is 3. Semi-annual compounding, and it's 6 years. All right, so we'll plug these numbers into this formula. So the principal is now 75. The rate is 3. The compounding frequency is 2. And the exponent is n times t, which is 2 times 6. All right, so when you simplify, you've actually got 75 times 1.015 to the 12th power. And when you multiply that out, 1.015 to the 12th power times 75 works out to be 89.67. Now remember, we're rounding to dollars and cents. And now the rest of this falls right into place. Let me just copy these. So you don't have to do it exactly this way, but I think this is the most logical approach. So now, remember, the principal is 75. We've got 89.67 minus 75 is 14.67. And then the simple interest, PRT, is 75 times 0.03 times 6 years. Okay. And that adds up to $13.50. Okay, so 3% of $75 for 6 years is $13.50. And now the difference, which is what we're looking for, is $14.67 minus $13.50, which is $1.17. Now it's not much, but that's because we only started out with $75. So that's what you would expect. All right, well, I think we're all caught up, or I hope we are. So tell you what, why don't you go ahead and do 21 based on what we did here. Okay. All right, let's see how that went. So what do we know? P is 1550. Rate is 0.05. Compounding frequency is twice a year, semi-annual. And this time, the time is 7 years. So I'm going to borrow this formula and change the numbers. Give it a minute. All right, here we go. The principal is 1550. It's 5% twice a year, and 2 times, this time it's 7 because it's n times t. And so when you simplify it, you'll have 1550. Now, here inside, you'll have 1.025, and the exponent is 14. And when you multiply that out, 1.025 to the 14th times 1550, after rounding it to dollars and cents, is 2190.11. Okay, great. So let's get the rest of the information. So we'll have 2190, 11 minus the principal, which was 1550, 640.11. Now the simple interest this time was 1550 times 5%, 7 years, and that will leave us with 542.50. So the difference between the two is what we're after. And that's 97.61. All right, good. So I hope we all got that. Okay, so of course this logic is exactly the same. The only hard part is making sure you're careful with the future value. All right, so here's what we'll do. When you're ready, why don't you start number 22, and let's see how you do. All right, when we're done with this, you'll be an expert in calculating these numbers. So yes, go ahead. 22 is right there at the bottom of the upper half of this sheet. So take that information and calculate the same information, the future value, total interest, simple interest, and finally the compound interest using this approach. All right, let's see. So for 22, we have P is 625, R is 0.08. The compounding frequency is 4 for quarterly, and then the number of years is 12. So we'll plug these in. So this time it's 625. And 8. Four. N is 4 again, and then T is 12. All right, so this time when you simplify it, you have 625 times 1.02 to the 48th power. So what does that leave us with? 1.02 to the 48th times 625 is 1692. All right, and that's of course after rounding it to dollars and cents. So now let's figure out the rest. There we go. All right. So A minus P, as you can see, is 1692 minus 625, which equals 991.92. The simple interest, PRT, of course, 625 times 2%, 8% for 12 years. And that works out to be 600 even. Okay. And then, of course, the difference is very simple to calculate in this case. $391.92. That's our compound interest. Now, you've noticed the amount of compound interest this time is a fairly large percentage of the total, which hasn't been the case up to this point. That's because it's a large interest rate. It's also for 12 years. So over time, the compound interest grows very quickly. In a lot of these other cases, like here, it was a small percentage. Here, a very small percentage, but that's because more time is going by and because it's a lot of interest. All right, so there's one more. Let's just knock that off and carry on with the next group. So let's try to do 23. And by now, like I said, you should be pretty good at this. So 23 is on the bottom here. Let's figure that one out and we'll go on to the next subject. All right, I think we're ready. So P is 2575. R is 4%. The compounding frequency is 4 and the time is 2. So we'll plug those into our favorite formula. $25.75. Let's see, the rate is 4, quarterly compounding. And this is only 2 years though. Okay. So here we can simplify this to 2575 times 1.01 to the 8th power. And so what does that give us? 2788, and rounding to dollars and cents, 36 cents. So what about the rest? So total interest, the difference between this amount, 2788, 36, and the original principal, 2575, is only 213.36. But it's a very short time frame. The simple interest is 2575. And the rate is 4. And of course it's 2 years. And that works out to be $206. So the difference between those two, 213.36 minus 206 is 736. Excellent. Hopefully everyone got that one. And so now what's coming up next is we're going to be looking at annuities. All right, now the annuity formulas, as you know, are a bit messier than what we're doing here, but not that much messier. We just have to be a little bit more careful about simplifying the formula before we do anything with it. All right, also one more thing, how do you know? Well, it says here, these are future values of an annuity, but the giveaway is that instead of having principal, which is a one-time only payment, we have payment, which means it's been repeated more than once. Okay, so these are annuities, and in each case, we're being given everything we need to know, which is to say, the payment R, capital R, I should say, lowercase r, which is the interest rate, the compounding frequency, which is, of course, is N, and the time, which is T. All right, so I'm going to go grab that formula from the slides because it's very, very messy. We want to handle it carefully. Let's see. What I thought I saw it. Here we go. So this is what we'll be doing for all of these cases. All right, so just a quick reminder, and again, it's up there, but let me do it again here again. A is future value. R is repeated payment. Lowercase r is their interest rate. N is the compounding frequency. And T is time, in years, of course. So for the first part, question 24, R is 200, lowercase r is 0.09, n is 1. Oh, you know what? Let me do this one more time. N is 1 for annually. Semi-annually means n is 2. Quarterly means n is 4, of course. All right, so n is 1 and then t is 9. So we're going to plug those numbers in. Now this time, all we have to do is find a. We don't have to do anything else. So we'll do that. And we will plug everything in and hopefully simplify it properly and come up with the correct result. So R is 0.09, N is 1, N is 1, T is 9. Okay, so when we simplify this one, it's not really going to be all that simple, but we have to take a shot at it because otherwise we're bound to make mistakes. So how can we simplify this? We have 200. So this expression is 1.09 to the 9th power minus 1 all divided by 0.09. So again, what you should probably do is calculate 1.09 to the 9th minus 1 first. So if you do that, you get approximately 1.17189, let's say. That's probably close enough. And then 0.09. And then that should work out to be approximately, within dollars and cents, 2604.21. Okay, so remember, the only thing you have to worry about with the accuracy is you ideally like it to be within dollars and cents. And so that's the final answer. That's it. That means if you put $200 away once a year for 9 years, when the rate is 9%, at the end of those 9 years, you'll have 2604.21. We're not going to break it up into interest and principal. It's too messy, but that's the point of it. All right, so why don't we do this? Let me split the screen up again so you can see what we're doing. And why don't you take a crack at number 25? All right, those are the numbers, and I'll leave this here so you can see what we're actually doing. This formula is all you need. So plug in the numbers for 25, and let's see what you can come up with. Okay, so those are the numbers we have. So I'm going to plug these in. And of course, I'll replace them all with the correct current numbers. So this time it's 750. The rate is 3 instead of 9. It's annual compounding. And the number of years is 12. All right, so when we simplify this, let's see what it turns into. $750. Now, here we've got 1.03 to the 12th power. And in the denominator, we have 0.03. All right, so then you'll have 750. And 1.03 to the 12th minus 1 is 0.42576. In the denominator, we have 0.03. And so finally, our final result will be 10,644.02. Okay, so that's the future value of that annuity. So let's see, what else do we have here? So if we look at the rest of this problem set, we still have 3 more of these to do. And then down here we have, now here we're calculating the effective annual rate, EAR, from APR. I just want to point out these numbers you're seeing here, these are the APR. And this is the compounding frequency. Okay, so here, n equals 4, n equals 2, n equals 4, and n equals 2. And so you're going to calculate the formula. Let me go get it out of the slides as a quick reminder which one this is. This one, right here. This is it. Okay, so then the rest of the problems are word problems. And so you can see what you have to do is figure out which ones they are, but they'll all be similar to something else you've seen in the same problem set. There's nothing completely new down here. Okay, so why don't we do this? I'll post this one today with the understanding that it's incomplete, and that what I'd like you to do is finish it up, or at least review what we've been doing. So remember, we still have to do these 3, the APRs, EARs rather, and then all the word problems, and then we'll be done. Now, when this is done, what we should probably do is start working on the sample midterm, but because we're not completely done, why don't we do this? We'll finish this on Thursday, and then we'll start the new chapter just very briefly. And then next week, we'll do the sample midterm, which is, let me go get it. Just because this way you'll have more time. The sample midterm is a lot like this one, except that it has these short fill-in questions. We don't have that. We haven't had that up to this point. The rest of it is pretty much identical to what we've been doing. So let's agree. And in fact, maybe I'll put in the announcement. Just a quick reminder. I always forget to do this. So we'll do the sample midterm. We will finish the chapter 8 problem set on Thursday, and then start chapter 11 just briefly, just to take a look at it. We will then cover the sample midterm number 2 on Monday, the 1st. Believe it or not, I will then post the actual midterm number 2, which will be due as usual a week later or so. Now, by the way, this one is a lot shorter. I mean, this is a single chapter, so it isn't quite as many questions, but it might be a little more complicated. So this is where we're going in the next week or so. And now chapter 11 and 12, which is our last 2 chapters of the course, will be the entire final exam. Now, they're fairly long chapters and they're a very different subject matter, but something that I think you'll find extremely interesting. All right, so I'll let you know about that later on. But right now, I think this is what we should do. And then that way we know exactly where we're going. And I want to apologize for not having your exams ready, the first one yet. They'll be ready by the time I see you again. Don't worry about it. So in fact, I'm going to post the scores in Moodle rather, so that you can look at them. I don't know if it'll send you an email once I've posted them or not. So you might want to check right around Wednesday or so. Check out your Moodle, and I'm hoping that you'll be able to see the numbers that I put in there. Okay, so that way you don't have to wait until Thursday to find out how you did. Now, if you want to ask questions about the first midterm, and like if you're not sure why certain questions are wrong, or anything along those lines, we can certainly go over that in class. But in the meantime, let's focus on finishing up the chapter 8 problem set so that we can do the sample midterm next week. All right. So other than that, I guess I'll just see you all again on Thursday. All right.
Thank you.
Okay, see you later. Bye.